Hello, my name is Andrew Miller, and this video is about my project using machine learning to identify echo chambers on Twitter. An echo chamber, also known as a bubble, is a phenomenon in which the majority of the content a user sees is skewed toward only one viewpoint on a debated topic. And while not every person that's in an echo chamber has repercussions, in the case of online content, whether it be news, blogs, videos, or general social media, if a person is uninformed about a subject as a whole, it can lead them to make uninformed responses, decisions, and general cognitive dissonance. So the goal for this project was to use machine learning in addition to natural language processing techniques to analyze a person's Twitter content and determine whether that person is in an echo chamber. Specifically, this project focused on social and political topics that are controversial and would therefore have a range of views that either supported or opposed the topic. Data from Twitter was obtained for about 8,600 users on the topic of Obamacare and about 4,000 users on the topic of abortion. The dataset was comprised of users' tweets that contained keywords about a topic and that were posted several days around an event that triggered discussion about that topic. For each user, we obtained their Twitter ID, an average of 5,000 tweets, and a predetermined correct political leaning for that user that was found by an independent source that considered tweets that contained links to news organizations with a known political leaning. The user was then placed into one of 5 categories based on their leaning, one of 2 extremes, 2 moderates, or a neutral class. After noticing the large disproportionate classes affected the machine learning's ability to learn, the number of samples was trimmed to take 500 random samples per user from each class to ensure an equal distribution. The tweets were cleaned by removing features such as links, capitalizations, and stop words. 15 baseline machine learning algorithms that are commonly used for text-based classification were implemented for general comparison. Highest scoring runs achieved upwards of 90% accuracy, but were found in reality to be closer to 80 or 85% accuracy once cross-validation was added. This was true with both the hashing and TF-IDF vectorizer. The next step was to reduce the feature space from millions of words using word embeddings, which attempt to find the context, semantic, and relations of words in a document with its surrounding words. 2 types of embeddings were used, the GloVe pre-trained model as well as a custom trained word-to-vec embedding. A few examples are shown. Then using a linear SVM, which is one of the high-scoring previous models, both embeddings were tested, each with a mean and a TF-IDF weighting scheme vectorizer, and they achieved validated accuracies around 80%. Then following the steps of past related work, a one-dimensional convolutional neural network with an atom optimizer was implemented. The architecture used the previous mentioned word embedding layer as the inputs, which were then passed through a ReLU activation function, 3 convolutional layers, had max pooling for downgrading, and a softmax activation function on the outputs to predict which of the 5 classes a user belonged to. Using 20 to 50 epochs, the CNN was able to achieve a cross-validated accuracy of over 90%. So now that a user's bias on a topic could be accurately classified, a user network was constructed. The social network is a connected network based on follower-followee relations. For the Obamacare dataset, the 8,600 users were densely connected in the graph with over 1 million edges. In this network, an echo chamber is characterized based on a user's immediate network and a measure of a homophily score. Homophily is the tendency of a user to link more with those that share similar views. So the higher the homophily score, the more likely that user is inside an echo chamber. The users fall into one of 3 types of categories: partisans, who are extremely polarized, bipartisans that have a neutral view, and gatekeepers who are not in an echo chamber as they have balanced exposure to both sides of the topic, but they clearly express agreement with one side. As can be seen, an alarming number of users have a high homophily score. And when we look at partisan and bipartisan users, we see that a large number of partisans have a high homophily score and the opposite for bipartisans, which is as expected. The final step was to determine the one-sidedness or cohesion of a user's local network in the graph. The higher the cohesion score, the more a user was buried in an echo chamber. As can be seen, an alarming number of users had a very high cohesion score, which meant that a huge number of these Twitter users were in fact in echo chambers. Shown here are tweets from a randomly polled user and several random connected friends that were found to be in strong echo chambers that only voiced opinions against Obamacare. As can clearly be seen, the partisan user expresses strong opinions against Obamacare, as do the users that they are connected to. The same can be seen for a random user on the other side. Knowing that all of the connections express the same views means the users never see both sides of the issue on the Twitter feed, and they are indeed in an echo chamber. To summarize, this project resulted in a very capable machine learning convolutional neural network that can accurately predict a user's bias on a topic by analyzing only their tweets, and then analyze the connections to that user on the Twitter network to determine if they are in an echo chamber.